Welcome back to the Foundation in C# course. We're currently in Module 2, and this lesson, we're going to actually do a mini project. So this is something that'll pop up quite a few times throughout this whole series. And what we're going to do is mini projects take a group of things that we've learned and put them into a little bit larger of an application. And the reason for that is because sometimes we learn things kind of in a vacuum or on their own, and it's hard then to figure out how to integrate them. And so a mini project kind of forces you to integrate these things that you've learned so that you can make sure that you understand at a small level before you get to the big level and go, oh no, I don't know how to do this. If you've watched any of my other content, you've probably seen my start to finish series. Well, with a start to finish series, what that does is it's a larger project, not a mini project, but it's a larger project where it takes all these different pieces that you've probably learned and it puts them together and makes sure that you understand how they fit together. This is a similar type of thing, but it's just on a smaller scale, so it's not quite so time consuming. We won't spend 20, 30 hours on putting together a project here. We're just going to do smaller ones that help it fit together. Now, right away, this is a little bit different of a lesson. So instead of going into code first, we're going to go right to our pro tip. The pro tip for this lesson is always plan a project before you start to code it. And I use that word always. I almost bolded this, made the font bigger, underlined it, italicized it, put arrows to it. Like always should jump out at you as a very clear statement. It's not a we should do this. It's not a it's a good thing to do. It's always. Because the times when you don't are when you find out you have a problem afterwards. And you're like, oh no, I messed something up. So always plan a project before you start to code it. That will protect you from some of the mistakes. The area you have the most bugs in, the area you have the most problems in, the area that's most difficult to code or is difficult to update and maintain is usually the area that you didn't really plan out before you just started doing it. And the temptation is, as you get better at programming, that you're just going to open up Visual Studio and start coding away because you've got an idea and you think you know how it's going to go. That temptation is very strong and it happens a lot, especially to newer developers. And what happens is you think you know, and then you work yourself into a corner. And once you work yourself into a corner, you go, oh no, I need to account for this. And so you try to rework your existing code, which means maybe code gets left out, or maybe code doesn't work the way you thought it was going to work, and so it has the wrong naming convention, so it's just a little bit off. Or other things that happen that cause your application just have this extra difficulty to them, where planning would have made that clear from the beginning. Planning also points out the areas you just don't know. Because if you're trying to plan out an application and you have those steps where it's like, step 1, do this, then something happens, and then step 3. And it's like, whoa, what's the something happens? If you can't define it on paper or to a person, then you can't build it into code. You can't just assume that middle step there is just going to magically appear. So that plan helps you go, oh wait, I don't know how I'm going to do that. And then maybe you build a couple sample projects to figure it out. And then you go, oh, yep, that's how I'm going to do that. And now you have a clear step 2. Great. Now you're ready to go on. So again, just super emphasis here. Always plan a project before you start it. Now that brings us right into our homework. And again, this is kind of backwards in some way from our normal lessons. And that's on purpose. So the homework for this lesson, before you continue this lesson, I'm going to have you do our project before I show you how I do it. So the homework is to plan and build a console application. Let me stop you right there. When I give you information, I'm being very, very clear about what I want. When you get in the real world, it won't be nearly as clear because your boss might not know that he or she wants a console application. So you have to learn to read requirements. And so I'm going to practice this with you by giving you more and more vague requirements that I want you to accomplish. So we're starting off with very specific requirements, but as we go, we'll get a little more general just to kind of give you that feel for how it's going to be in the real world. Because that's the full point here, is we're focusing you on the real world, not just on being able to do sample stuff. So right away, we have one of our requirements is console application, which means you can't do it in WinForms. You can't do it in ASP.NET MVC. You have to do it in console application. That's a requirement. Now, the next thing is it says the application that will ask for a user for their name and their age. Now, it doesn't say just their first name and their last name and last name together or apart. It doesn't answer that. It just says their name. That's up to you to choose how to ask for it. Now, if their name is Bob or Sue, which kind of gives you a context clue for what the name we're asking for is, probably first name. If their name is Bob or Sue, address them as professor. Next, if the person is under 21, recommend they wait X years to start this class. Meaning, if they're 18, you should wait 3 years to start this class. But remember the previous requirement, if their name is Bob or Sue, address them as professor, which gets a little weird. So, for example, if Bob was 19, we would say, Professor Bob, I recommend you wait 2 years to start this class. If it was Frank, and Frank was 28, we'd say, welcome to class, Frank. If Sue was 22, we'd say, welcome to class, Professor Sue. But then if Marjorie was 17, we'd say, Marjorie, I'd recommend that you wait 4 years to start this class. See how that works? So we're going to address them as Bob or Professor Bob or Professor Sue, or anybody else just by their first name. And we'll either say, welcome to class, or we recommend you wait however many years it is until you're 21. So right now, I'd like you to pause the video, plan out on paper first what you're going to do. And then once you've planned out what you're going to do on paper, then open up Visual Studio and do it. Don't open up Visual Studio first. You could. And you know what? You'll probably be fine in this first lesson. But that's not what I want to teach you. I want you to get in the habit now where you go first to paper or to a whiteboard or to some other medium for physically writing down your plan. Okay? So pause this video and then come back to it once you're done your application. All right, so hopefully you got your application done by now. Now I'm going to show you what I would do. Now I'm going to do it in Notepad so you can see it on the screen instead of me writing it down on a piece of paper and then taking pictures of it or something like that. Because I want to walk you through the thought process too. So here I have my requirements. And by the way, Notepad I use all the time. It's just so simple and easy. I usually have 3 or 4 Notepad versions open at the same time, or windows open at the same time. Just because it's easy to dump information in and then clear it back out. So here I have my requirements. So let's map out what we need to do. Well, the first thing to do is ask for the user's age, or name, sorry. And since we saw that it's first name, the first name is being used, Bob or Sue, then we're going to say first name. To be very clear to the users, I don't want Sue Storm, I want just Sue. Okay? Ask the user for their first name. Ask the user for their age. They might even want to specify numeric value. We'll see. But we want to ask for the user for their age. Now we're going to use that age. So the next thing we need to do is we need to convert age text to age. string to int. Okay, so it's being very clear what we're trying to do here. We're going to convert the age text, because don't forget, when we ask for their age, it's going to be a string. We convert that to a number or an integer or a whole number so we can perform operations on it. Like if they're under 21, recommend they wait. And how many years? So the next thing we need to do is we need to identify if they are under 21. So, and here's the thing too. If you don't know how to do something like this, if their name is Bob or Sue, address them as professor, if you don't understand how to do that yet, what I recommend is do what you can do and then go back and look at it in this text pad or on a notepad and see if you can't fit it in somewhere. So I'm just going to do the if statement for right now. If the person's under 21, because that's actually that's the actual statement I need to do. If age is less than 21, okay, and in fact, I'll put curly braces here just because this is what's called pseudocode. It's not really code. It's just, it's similar enough that it allows us to do some things with it. And I'll put my else here just so I have it. So what are we going to do here? Well, we need to say, wait so many years to start this class. So we'll need to do a calculation here where we say, we could either capture that or we could do it right in line. So for example, we could say, I recommend you wait and say 21 minus age, because that'll give us how many years to start this class. So I recommend you wait 21 minus your age. These are less than 21. So if they're 20, it's 1 year to start this class, which 1 year is a little awkward. But for now, that'll work. But the problem is it doesn't address the professor yet. So we'll get to that. And we haven't, let's put their name at the end. So I recommend you wait however many years to start this class, Tim. Else, welcome to class, Tim. So that's how our flow is going to go. But now you have to figure out, what do we do as whole if Bob or Sue address them as professor? Well, one of the things we could do is instead of, we could put if statement here. So you'd wrap this whole thing right here in if statement. If first name equals Bob or first name equals Sue, then say, professor and their name, else just say this. That's one way of doing it. Another way of doing it would be up here after we convert their age text, or before, doesn't really matter. We can have another if statement and say if name, or first name is going to be, equals Bob, or name equals Sue. Notice I'm not using quotes, and I'm not using parens and all the rest of the stuff that you normally would. Again, just pseudocode, just to give me the idea of what I want to do. So if the name is Bob or Sue, then I'm going to, let's put our curly braces here just so I can delimit. I'm going to say that formatted name equals professor name. And I can do an else here and say that the formatted name equals just the name. All right, so now we could say down here, formatted name and formatted name. So if the name is Bob or Sue, then we're going to say that the formatted name is Professor Bob or Professor Sue. Otherwise, we're going to say that the formatted name is just Tim. And so then when we say, I recommend you wait 4 years to start this class, Tim, or welcome to class, Professor Sue. So I think that meets all of our requirements. And that's the next thing to check, is you come up to the top and you look at your requirements and say, console application. Well, yep, we're going to do it in a console. Ask the user for their name. Yep, we did that right there. And their age. Yep, that's right there. If their name is Bob or Sue, address them as Professor. Well, that's what the formatted name thing does. We got that. If the person is under 21, recommend they wait X years to start this class. If less than 21, I recommend you wait to start this class. Otherwise, I said welcome to class, just to have something to say to a person who is over 21 or is 21 or older. Now, you see how I mapped that logic out? I didn't just start coding it, which I could have done. And the reason why is because this whole name equals Bob or name equals Sue thing kind of threw me for a little bit of a loop. I didn't know how to deal with that at first. And so when I figured it out, I'm like, oh, I'll put it up here and I'll make it a formatted name. Well, I would have had to go on back and change this code down here to be formatted name versus name, which I did in my text file. But if I have to do that in code, I might forget one of those and just display name, not formatted name. That's what's called a bug. Because then, may I forget this one down here where it says, welcome to class, Tim. So I try it with a person that's over 21, it works. And maybe I think that both Bob and Sue are over 21, so therefore I never test it. I'm sorry, or under 21. So I never test it with a person that's over 21 who's also a professor. But then we get to production, and in production, someone says, well, Bob is 85. And it says, welcome to class, Bob, not Professor Bob. That's a problem. So that's why I do it on paper first, not actual code. This is a lot of specifics. And that's because of the intro level we're at. And that's fine. And as you go, the specifics will get less and less. But the actual flow should go on paper first. That way, you can rework these things and not introduce potential bugs as easily. Because if you, even if I forgot this, and it said name, well, when you came to put this in the actual code, you're going to go, wait. Why is it name and not formatted name? And you'll fix the bug then because you've reviewed it. All right, so I'm going to copy this entire thing. You go over here and we're going to start a new console application. So console app, call it console UI. And this is module 02. And it's what I'm doing right here. And I know I've completed this step. Ask the user for their age. Console.write. What is your age? And I'll just leave it at that. I'll assume people know numbers, but it's up to you if you want to assume that or not. And I'll say string age text equals console.readLine. And now we're going to convert the age text to age. Well, we know how to do that. Bool is valid age equals int.tryparse age text and out int age. Now here's a tricky bit. What are you going to do if they give us an invalid age? I think the best thing to do is to just close the application. So I'm going to say if, and this is not in my design, but it's something I'm going to add to my design. If is valid age equals false. I'm going to do a console write line and say that was not a valid age. I'm going to do a console.read line. And then I'm going to do a return. So what this does is going to write out to the console that was not a valid age. Now, the next thing I do is do a read line. And remember the read line, what it does is it pauses the application, allows us to see what's on the screen before we give some kind of input. When I don't capture that input, it's because I'm just wanting that pause functionality, not the actual value of whatever they give me back. So when they hit enter, what's going to happen next is a return. A return is essentially, it closes out this function or this method. So this static void main, it's going to say, you know what, we're done now. Don't do the rest of the code. So return closes out and basically comes down to the very end curly brace here and says, yeah, that's how far we've gotten now. Which means the application will close. So you don't give a valid age, we close the application down. You have to open back up and try again. That also means I don't have to put everything else in else statement. Because if it's going to go away right here, then anything else down below is as if valid age was true. So I don't need an else. So now I can say I'm going to do this code. Now I won't leave this pseudocode in place. I'm going to copy the format or what it does. So if first name equals Bob, I'm going to say that's lowercase Bob. And the reason why is because it's a type uppercase B, lowercase o, uppercase B. That wouldn't match. You have to match exactly. And so what I'm going to do instead is first name dot to lower. And what to lower does is it converts this first name value to all lowercase versions. So it doesn't matter what the casing is for first name. If it's comparable to all lowercase Bob, that's going to match. And we'll do the same with first name dot to lower equals Sue. Now, if you were to say capital S here, that would never match because to lower ensures that all the characters are lowercase. So therefore, you have to be very careful to make sure that this is also lowercase. So if either of these two match, I come down here and do this logic, which this logic says the formatted name equals professor. Well, I don't have that variable yet, so let's create that variable. And I'll start it off with an empty string. I'm going to say formatted name equals, I'll do my $ syntax here. I'm going to say professor and then curly brace first name. Notice it's not to lower here. Now this to lower doesn't affect the actual first name variable, it just acts upon it, which means the comparison only lasts right here. So this is going to be lowercase Bob, but if it was proper casing for first name, it'll be proper casing over here. So it's not modifying what we already have. So say Professor Bob or Professor Sue. And we'll do our else and say formatted name equals first name. And that's because anybody else is not a professor, it's just their name. So now I can kind of get rid of this logic that I just completed and move on. So let's follow the logic. And again, notice how easy this is now. I'm just following the pattern that I've already set up. I don't have to think necessarily about the flow of it. I can focus on one little piece at a time and just make sure that piece is what I want it to be. So if age is less than 21, we're going to say console write line. I recommend you wait 21 minus age. Now notice it's not highlighting for me. That's because I don't have the $sign first. I recommend you wait 21 minus age years to start this class, and then their formatted name. Okay, so that's our one side of it. The other side, the else, is $, double quotes, welcome to class, formatted name inside those curly braces. And that takes care of that logic. So there we go. There's our application. And if we read back over the requirements, console app, yep. Ask for a user for their name, yep. Their age, yep. If a name is Bob or Sue, address them as professor, yep. If a person's under 21, recommend they wait X years to start this class, definitely. So we've got all this in code. Now let's verify it all works. So we're going to run this application. We're going to run it a few times. What's your first name? Well, my first name is Tim. What's your age? Let's go with 40. Welcome to class, Tim. Okay, so we've tested now that a non-professor over the age of 21 gets the right message. Now let's check to see if a professor over the age of 21 or 21 or older gets the correct message. So notice I'm doing my casing of capital S, and it's still finding that comparison. Your age, let's say 25. Welcome to class, Professor Sue. So that worked. Now let's try the other side of things. My first name is Tim, and I'm 14. I recommend you wait 7 years to start this class, Tim. 7 plus 14 is 21 years. And notice it's just Tim. Now, let's say that the first name is Bob. Age is 11. I recommend you wait 10 years to start this class, Professor Bob. Again, that worked. So 10. Oh, yes, we want to have clean code and proper code and code that's easy to maintain and all the rest of the stuff. But job 1 of your code is to get the job done. Job 2 is to make sure you do it well, as in optimized and easy to read, easy to maintain, those type of things. So you could have gone about this in a different way and still got the same conclusion. And that's great. All right. I hope you've enjoyed this. And once you've kind of relaxed and cooled down from this lesson, time to move on to the next.